In part 2, 2.6, we're going to be specifically talking about composite functions. So the composition of functions, we can have the composition of f with g, and it has this symbol. It almost looks like an O in the middle. So the composition of f of g of x, and that means the function of g of x. F times the function g of x. The domain of the composite function is the set of all x, so the x is in the domain of g, and g of x is in the domain of f. And that'll make more sense as we do some examples. So let's go ahead and form a composite function. So the main thing is this is not a multiplication sign in between the f and the g. It's meaning the composition of them. So we have f of x is 3x minus 4, and then g of x is x squared minus 2x. So the first step, we know that this, we just learned, means the same as this. So we're going to replace every x in f's equation with g of x. So I'm going to just remind you of what we've been doing on past lessons. If we had this and we want to know what is f of 4, we went in and replaced every x with a 4, right? So this time, instead of a number, we're replacing it with the entire function g of x. So we're going to take f's formula and each occurrence of x I'm going to replace with g of x. So I'm going to put g of x here, and I'm going to put g of x here. Then bring everything else down. Okay, so specifically for g of x, I already know what that is. It's up here. I have x squared minus 2x plus 6. So this is going to equal 3. Then I'm going to replace this with x squared minus 2x plus 6. Then I have that minus 4 on the outside. So if I distribute, I have 3x squared minus 6x plus 18 minus 4, which reduces down to 3x squared minus 6x plus 14. So that means if I go back to what I was looking for the composition f of g of x. Here would be our final answer. Okay, let's try a similar one. This time I have the same things, but now the g is coming first. So I'm saying that g with f of x is the same thing as that. So now I have each occurrence of x I'm going to replace in g's equation with f of x. So I'm going to take g's equation and everywhere I see x, I'm going to replace it with f of x. So here's an x, I'm going to replace it with f of x. And don't worry if you make a mistake with all these parentheses. Sometimes it can get confusing on how many to put in there. I mainly have so many because of that squared symbol at the beginning. I want to separate it out, make sure that entire quantity is squared. So now I'm going to replace what I know f of x is right here. And again, that whole thing has to be squared. And here I can also put what f of x is. So it's just a lot of substitution, and then you're going to be simplifying. So here I have 3x minus 4 squared. So that's 3x minus 4 times 3x minus 4. And I can distribute negative 2 times negative 4 is positive 8 plus 6. So now let's keep going with FOIL. This would be 9x squared minus 12x minus another 12x plus 16. Bring everything else down. I'm running out of room, so let's simplify it up here. I only have one x squared term. I have negative 12x minus 6x. So that's minus 30x. And I have plus 16 plus 6 plus 8 would be plus 30. So my formula ends up coming out to 9x squared minus 30x plus 30. So this is not the same as the last one when the f came first. So there is definitely a difference between the two. Okay, now we're going to have a number instead of an x here. So we just found what this was on the last slide. So now we can go ahead and replace every x with 1. So here's what we had found. If we hadn't already found that, then you'd have to go through, solve for that, and then go in and replace all the x's with 1s when you're done. So replace every x I see with a 1. So that would be 9 times 1 is 9, minus 30, plus 30. We end up just getting 9. So we have the proper way to write this. Write what they were asking and then put what you found. Okay, let's try a similar one, but this time I changed it to a negative 1, and I changed our original formula. So another way you can do this, if it's just asking you for a number here instead of an x, you can work from the inside out, is how I like to think of it. So we have negative 1 is what we're trying to find. So first we're going to work with what is g of negative 1. So let's do that first. So if I'm trying to find g of negative 1, I'm going to go to my g formula. And replace every x with a negative 1. So a lot of negatives here. Make sure you're careful with those. So g of -1 would be -1 squared is 1 times 2 is 2. -1 times -1 is +1 minus 1. So g of -1 is simplified down to 2. So now I'm going to use this. I just found this piece right here is 2. So now I can find what f of 2 is. So our original f of x is 5x plus 6. So if I replace my x's with 2, f of 2 would be 5 times 2 plus 6, which is 16. So our final answer, we said we were trying to find this. So I'm going to write that. We got positive 16. So again, we ended up doing f of 2 because we found g of -1 was 2. So really I could just go from there and finish it out to find the f of 2. Okay, now we need to figure out what values could not work for the domain. So if x is not in the domain of g, it must not be in the domain of f with g. Any x for which g of x is not in the domain of f must not be in the domain of f with g. So if it's not in one, it can't be in their combination pretty much. Okay, so we know on this one, we have f of x equals 2 divided by x minus 1. G of x is 3 divided by x. We want to find what f with g is. So we have that this again means this function. So we're going to go and replace all the x's in f's equation with g of x. So we're going to start with the f of x formula. And I'm going to replace all the x's with g of x. So normally we just have a basic function, f of x. This time we have f of g of x. So it's just a little more complicated, but you're going to just replace all the x's with g of x. So g of x is right here. And I guess let me just put g of x here so we know that's what we're replacing it with. Replacing this x with g of x and then subtracting 1 from it. So now I can simplify that down. G of x is 3 divided by x. So I replace that there, and then I need to subtract 1 from it. Okay, so we have an issue in this denominator. We have pretty much another fraction within a fraction. So we need to figure out how to get rid of that. So if we multiply this whole thing by x, you also have to do it to the top. We would get 2x on the top. Then on the bottom, we're taking both of those things times x. So really we have 3 of x, or 3 divided by x times x minus 1 times x. So I kind of did a distributive property there. So now something nice happens. My x's cancel here. So I'm left with 2x on the top. Then I just have 3. Then minus 1x. I'll just put minus x. So what we were trying to find was f with g of x. And there's our answer. Okay, now let's talk about the domains here. So we have some issues because we have denominators and we know those cannot equal 0. So to find the domain of f with g, if you look back at the restrictions a couple slides before this, if x is not in the domain of g, it must not be in the domain of f with g. So let's see what would not work for the domain of g. So just g of x was 3 divided by x. So we know that the bottom cannot equal 0. So x cannot equal 0. That is going to be something that's not going to work for g, so it's not going to work with f with g. And we also said that any x for which g of x is not in the domain of f must not be in the domain of f with g. So we just found that f with g of x equals 2x divided by 3 minus x. So what's not going to work for this domain? Well, this cannot equal 0. So if I solve that out, if I minus the 3, I have negative x cannot equal negative 3. So really I have a negative 1 out front there. So if I divide by negative 1, x cannot equal positive 3. So it cannot equal 0 or 3. So if I think of my number line, just put 0 in the middle here. Okay, we know it can't be 0, and we know it can't be 3, but it can be anything else. So it could be anything up to the 0 and below it. It can be anything between the 0 and the 3. And it can be anything above the 3. So to write that, we can go from this negative infinity over here up to 0. Then we can go between the 0 and the 3. Then we can go from the 3 to the infinity, positive direction. So this would be our domain right here. That is the domain of f with g. So again, these just take practice. Let's try another one. So we have 4 divided by x plus 2 and then 1 divided by x. We want to find f with g. So we said that this means this. So I'm going to take my f formula, which is right here. And every time I see an x, I'm going to replace it with g of x. So put a g of x in place of that. And g of x is 1 divided by x. Okay, so I have the same issue I had on the last one. I have a fraction within a fraction. So on the bottom, if I multiply everything by x, that's going to help. Multiply the top also. So I'd have 4x. Then I'd have 1 divided by x times x plus 2 times x. And now my x's can cancel, so I'm left with 4x. Then I just have 1 plus 2x. Therefore, f with g of x equals 4x divided by 1 plus 2x. Okay, let's practice finding our domains here. So we said if it doesn't work for g, it's not going to work for f with g. So we know that x cannot equal 0 on the bottom of this one. So one restriction is x cannot equal 0. And then we just found that f with g is 4x divided by 1 plus 2x. So this bottom also cannot equal 0. So if I minus 1, I'd have 2x cannot equal negative 1 divided by 2. Therefore, x cannot equal negative 1/2. So on this number line, I'm going to number it. I'm going to put some halves here. So 1 would be about right here. So I know I cannot be at negative 1/2, so I can go up to negative 1/2 or down to negative infinity. So let's go ahead and put our domain here. So negative infinity to negative 1/2, parentheses. Then I can have anything above negative 1/2 up to 0. And then anything from 0 and above. And those should all be parentheses. Okay, so that is my domain. Okay, example 7, we're going to write a function as a composition. So express h of x as a composition of two functions. So something got put together, two functions got put together to make this one. So we know what would those be. So we know there's a cube root involved. So let's make that f of x. There was a cube root. And then we also know that something got put under the cube root. We'll call that one g of x. Is the portion under the cube root. So we know that h of x took x squared plus 1 and then its cube root. So that's how I process through this. So that means h of x, we had the g. Something was done to the g first that got put into f's formula. And these are the two that made that. So I'm just showing you how that order worked, because this means the same thing as f of g of x So what happened was we took the f of x formula and we put g of x into it. And that's how we got the cube root of x squared plus 1. So the main thing it's looking for is what I have in the box, but I did want to explain how I found that. Okay, just one more you can look at. What two functions made this? So we know that one way we could make it work is if f of x was the square root of x and g of x was x squared plus 5, then we have f with g of x gives us h of x. So again, if I think of what this means f of g of x so we took what f of x was, which was the square root of x, and then we replaced our x with g of x. So we put g of x in here. Which was x squared plus 5. Okay, so again, that one I know is a pretty tricky lesson. They just take lots of practice, lots of substitution. So look at your notes, make sure you do your homework and do the extra practice, and reach out if you still need help.